Hey everyone, and welcome to this A1 Institute Explainer. Gearing up for your Class 10 finals? Then you are in exactly the right place. Today, we're digging deep into a topic that's literally the foundation of our country, the soils of India. All right, let's get right into it.
Okay, I'm going to start with a question for you. What do you think is India's most vital, yet most overlooked, resource? Think about it. It's not gold, it's not coal, it's the very ground we walk on. Yep, it's soil. And you know what? Really understanding it is a huge key to crushing that geography paper. So let's break it all down.
All right, first things first, we're going to take a quick tour of India's major soil types. Now, knowing the difference between them, super crucial. This is where you're going to score some serious marks. Let's do this. Kicking things off, we have laterite soil. And here's a little exam hack for you. The key to remembering everything about it is hidden right in its name.
So take a look, you can see that really distinct reddish-brown color, right? That look is a total giveaway about how it's formed in really rainy places. Let's dig into that right now.
Okay, so here's the absolute money shot. The name laterite comes from the Latin word later, which literally means brick. And why is that? Because this stuff gets rock hard when it dries out, just like a brick. You'll find it in places that are super hot and get a ton of rain. And all that rain leads to this process called intense leaching. Basically, the rain just washes all the good stuff, the minerals and nutrients, right out of the topsoil. This makes it pretty acidic. Now, that might sound bad for farming, but actually, with the right kind of fertilizers, it's perfect for growing things like tea, coffee, and cashews in places like the Western Ghats and Odisha. Just burn this into your brain. Laterite equals brick.
Okay, moving on to our next soil type. And we're going from one extreme to the other. From the super rainy places that create laterite, we're heading straight to the desert for arid soil.
And wow, what a contrast, right? This is what you'd expect. Dry, sandy, and totally exposed. Just looking at the landscape tells you almost everything you need to know about this soil.
So, arid soils, they're sandy and they're saline, which just means salty. And that's because it's so hot and dry that any moisture evaporates super fast, leaving all the salt behind. They're missing two key things, moisture and humus. And humus is just that good organic stuff from dead plants that makes soil rich. Another key term you got to know here is conchar. It's basically this layer of calcium carbonate that forms down below, and it acts like a concrete barrier, stopping any water from soaking in. But here's the cool part. Even though it sounds pretty useless, with proper irrigation, this soil in places like Western Rajasthan can actually be used for farming.
All right, let's clear something up that trips a lot of students up. The deal with red and yellow soils. Are they different? Well, kinda yes and kinda no. See, red soil gets that reddish color because of iron that's diffused in the rocks. But when that exact same soil gets wet, when it gets hydrated, it turns yellow. So really, they're just two versions of the same thing. One's dry, one's wet. Simple as that.
Okay, so we've talked about all these amazing soils as a resource, but this resource is in big trouble. So let's switch gears and talk about a huge problem, and one you absolutely have to know for your exams: soil erosion.
All right, get your notebooks ready, because this is the textbook definition you need to know. Soil erosion is the denudation, that's a fancy word for stripping away, of the soil cover, and then it all just washes down. And yeah, this happens naturally, but let's be real. Human activities have hit the fast forward button and made it way worse.
So, what does this erosion actually look like on the ground? Over on the left, we've got gully erosion. This is what happens when water cuts these deep, angry channels into the land. You can't farm on that, it's just gone. And on the right, you see sheet erosion. This one's a bit sneakier. Imagine water flowing like a giant sheet, just shaving off the very top layer of soil. It doesn't look as dramatic, but trust me, over time, it's just as destructive.
So, what's causing all this? Lean in close, because this is a classic exam question. The main culprits? Well, they're mostly human. Cutting down forests, letting animals overgraze, massive construction projects, and mining. Even just using the wrong farming methods can do a ton of damage. And of course, you've got the natural forces: wind, water, glaciers. They're the getaway drivers that actually carry the soil away.
But hey, it's not all doom and gloom, because for every problem, there's a solution. And that's what we're talking about next. Let's get into soil conservation, the actual practical things we can do to save our soil.
Okay, there are 4 key methods for conservation that you absolutely have to know. I want you to think of these as our 4 main superheroes for saving soil: contour plowing, terrace farming, strip cropping, and shelter belts. Let's quickly run through what each one is all about.
First up, contour plowing. The idea behind this is so simple, but it's totally brilliant. Instead of plowing straight up and down a hill, which basically creates a waterslide for the soil, farmers plow along the contour lines. You know, like you're following the curves of the land on a map. This makes tiny little barriers that slow the water right down, stopping that erosion in its tracks.
Next, we've got terrace farming. I'm sure you've seen pictures of this. It looks amazing. In super hilly places like the western and central Himalayas, they cut these steep slopes into a bunch of steps or terraces. Every single step slows the water down, which stops erosion, and, bonus, lets people farm on land that would otherwise be way too steep to use.
And finally, we've got a pair of methods that basically use plants as shields. With strip cropping, you take a big field and divide it into strips. You might plant grass in one strip and then corn in the next. That pattern helps break up the force of the wind as it blows across the field. Shelter belts do something similar, but instead of strips of grass, you plant long rows of trees to create a wall against the wind. This works wonders for holding sand dunes in place in desert areas.
All right, we have covered a lot of ground. Haha, pun totally intended. Let's wrap this all up with a quick summary that's perfect for your last-minute revision. You might want to get your phone ready for a screenshot on this next one.
Okay, think of this table as your ultimate cheat sheet. For laterite, just lock in intense leaching and brick-like. For arid soil, your keywords are high evaporation and sandy and saline. And for red and yellow soil, it's all about that iron and how it changes color. Nailing these key facts and where to find them will have you totally prepared for any comparison questions they throw at you.
And there you have it, our deep dive into the soils of India. I really hope you're feeling a lot more confident about this chapter now. Because, getting you prepped and ready for your exams is exactly what we do here at A1 Institute. So, if you want to go even deeper, maybe get some detailed notes, expert guidance for your boards, or if you just have questions about admissions, please don't hesitate to get in touch. Our phone number and all the details you need are right there in the description below.
And one last thing, if this helped you out, do us a huge favor. Hit that like button, share this with your friends, and most importantly, subscribe to the A1 Institute channel and ring that notification bell. We've got so much more great stuff coming your way, all designed to make sure you walk into that exam hall feeling totally confident. Good luck with your studies, and we'll see you in the next one.